Hey everyone, Mr. Shatter back with some more modeling and optimization, but this time focusing on economics. Objectives of this video to maximize and minimize functions within economics using derivatives. Let's get started. First, the theorem that's going to kind of guide this is maximizing profit. We already looked at this theorem last chapter, actually. Maximum profit occurs when marginal revenue equals marginal cost. So this theorem is actually quite easy to prove. If you know that profit, by definition, is equal to revenue minus costs, you take the derivative of both sides. The derivative of profit is just marginal profit, marginal revenue, marginal cost. And then since this is always defined, to maximize it, you would need to set it equal to 0. It doesn't have any undefined values. And then you can just add cost to the other side. So marginal revenue equals marginal cost. So this is a quick proof as to why marginal revenue does, in fact, equal marginal cost when profit is maximized. A quick problem to kind of drive this theorem home. A company manufactures X calculators, okay? They can be sold for this much each, and the cost for the company is this amount. And it wants to know, how could you maximize weekly profit? Well, in order to do this problem, we just need to find basically the max profit, and that will occur when marginal revenue equals marginal cost. So in order to find marginal revenue and marginal cost, you need to first find revenue and then cost. So let's start with revenue. Revenue, as we know by definition, is equal to the price times the quantity. Okay, and in this problem, it looks like the price was given to us right here. Here's the price, so that's 75 minus 0.01x dollars. And we're going to multiply that by the quantity, which is right here. We're going to make x calculators. So the revenue is equal to 75x minus 0.01x squared. So marginal revenue, if I take the derivative, is equal to 75 minus 0.02x. So this is the first function I'm going to need. Cost. I'm actually going to scooch it over a bit because it's kind of a big function. Ooh, drop the stylus there. That definitely happens sometimes. That's all right. C of x is equal to 1850 plus 28x minus x squared plus 0.001x cubed. So marginal cost is equal to that derivative, which is 28 minus 2x plus 0.003x squared. So our job is to basically subtract them, which in general is just going to be marginal revenue minus marginal cost equals 0. So marginal revenue minus, open up a parenthesis, marginal cost equals 0. So if I just distribute the negative, and let's put it in standard form, so what would that be? That'd be negative 0.003x squared minus it'd be plus 1.98x, and then it'd be minus 47 equals to 0. And then in order to solve this, I'm going to use the calculator for help. So let's go ahead and punch this into y equals. So it'd be negative 0.003x squared plus 1.98x minus 47. You know what? That minus 47 should be a plus 47, right? Because 75 and then minus 28, that should be a plus 47. I don't even think I used the parenthesis here. So that should be a plus right there. Check the 1.98 as well. That'd be positive, negative. Yeah, that looks good. Okay, this looks good. So now we're going to go ahead and find an appropriate window. Let's see. This actually, no, this window's not bad. Ironically, I don't know what this was, but so I want to look at the choices here and understand that the x values are going to be between 600 and 754. So why don't we go like 0 to 1,000? 0 to 1,000 and go up by hundreds? Sure. And then we'll graph this thing. And then we want to find the solution, which looks to be right there. So we're going to go second trace. We're going to go 0, and we're going to go left bound, which is, yeah, sure, over here. In right bound, we got to get to negative y values, right? We got to go all the way to negative y values. There we go, there we go. And a guess would be like, sure, let's go back. Oh, too hard. Let's maybe go right here. Looks like 6.82.94, 6.82. Oops, not sure why I had a decimal there. 682.940 approximately. So it looks like that will lead us to answer C, which is 683 calculators to maximize the profit for the company.